Hello viewers, good morning or good night because I'm filming at night. Good morning, and in this video I have the periodic table in front of me. Apologies for the this way of holding the periodic table. I'm rich enough to own a printer, but I'm poor enough to own one of the cartridges because after printing the demo message at my previous video, I found out my ink cartridge to be empty. At the what do you call it? It's not called ink cartridge. It's called LaserJet. Oh yeah, something like that. So I'm going in this video. I'm going to explain you group by group and period by period the different trends in periodic table, and we're gonna also talk about the transition metals, which is a big patch of metals in between periodic table. So beginning with group 1, ladies and gentlemen, is the far most group 1 has the most reactive metals ever. It's a metal group. One thing I have to point out at this point is that from group 1 to group 8 or slash 0, like going from left to right, the reactivity of the not the reactivity the metallic properties become less, and non-metallic properties increase. The metallic properties increase and non-metallic properties increase as you go from left to right in the periodic table. So starting from group 1, you can see from the trend that it has the most metallic properties, and it is far most highly the most reactive metals on earth known to man. For example, sodium, it can fizzes and it can explode and react in water, in air, in many things. So going down group 1, we also have uh, the element called francium. Since francium is known as the radioactive element, and since francium is difficult to find out its weight, by far known is that cesium, which is in group 1 of the periodic table, is far most the most cesium is far most the most reactive metal in group 1, or in fact in the known to man on earth. Now group 2 isn't that important, I believe. Group 3, there's before group 3 and group 2 we have a period called transition metals. Transition metals basically contain metals which have high boiling points and which have high melting and boiling points. Keep in mind of the high melting and boiling points of the metals in group 1, which we talked just a few seconds ago. Its melting point and boiling point increases as you go down the group, and it's also weakens as you go down the group, because if you compare the strength of cesium with, although you can't because cesium can react immediately, but if you compare the strength of lithium and let's say potassium is by far of softer metal compared to lithium, and cesium is more softer. So coming now on to transition metals, ladies and gentlemen, has one of the most high melting and boiling points ever known to man. Now there is nothing much in the transition metals except for the metals which are highly available on barely available on earth. Now in these metals we have two sections called acinoids and lacinoids. You can see that acinoids are laying down in the periodic table, and lacinoids are laying furthermore down, and there's a box where you can fit the lacinoids in. So as we go on to group 3, you can see that there is a general decrease in metallic properties, and we have at this stage group 3, 4, 5, you can see a staircase, and this staircase indicates the line in which the metallic properties go very low. So these are semi-metals. You can say most metals in group 3 and 4. These are called semi-metals. For example, aluminum is a semi-metal. Gallium at number 31 is also a semi-metal. Nothing much to do in group 3 except for the fact that they are semi-metals. Group 4 is also not that important, I believe. Group 5 has more non-metals compared to semi-metals, but still it has semi-metals. In group 6 we have it's neither that important, but actually for me, because I'm studying low-level chemistry at the moment, for me it's not important, group 3, 4, 5, 6, but group 7 is highly important for me. Group 7 is called halogens. No, noble gases. Yeah, halogens. Sorry, halogens. Noble gases is group 8. We're going there. So you can see that the group 7 needs only one, thus needs only one more valence electron to gain stability. Thus it makes it more reactive as you go, less reactive as you go down the group. Something's opposite here. The melting points increase as you go down the group, and also one more important thing in group 7 is that its color, it darkens as you go down the group. It colors darkens as you go down the group. For example, bromine has a darker color than fluorine. So moving on to group 8, which is my favorite group in periodic table, it's the noble gases. And noble gases are relatively, they need no valence electrons to gain electronic stability. And one more thing about group 8, actually three more things about group 8 is that group 8, basically the boiling point and melting point increases as you go down the group. The density of the gas, because the group 8 are noble gases, the density of the gas increases as you go down the group. And also the what yeah, they're also quite light, but not that light compared to hydrogen. Now here does a question appear, because helium and hydrogen is 4 times lighter than helium, which means that hydrogen must have more upthrust compared to helium on sea level. So the question here appears to be that balloons which are used in children birthdays, they're usually filled with helium. Why not hydrogen? Why hydrogen is barely used in our real life? That's for the simple fact because it is flammable. You can't, give little bombs on children's heads. You may think the children may think that balloon is a fun thing, but if you fill it with hydrogen, it's quite a serious thing. And hydrogen is also, of course, it's a part of water. We need it to fill our stomachs in a liquid way, and we also need different things like calcium, vitamin D. I'm not talking about that right now. So I hope this video became useful. This was just a brief description about the periodic trends in the periodic table. Detailed video is coming soon, probably 2 to 3 months after I have learned detailed trends in the periodic table. So thanks for watching this video. Subscribe to my YouTube channel, like the video, share the video, and bye bye. See you soon.